Hello friends, welcome to my channel The Integration. Presently I'm making videos on group theory. In today's video, I'm going to show you the uniqueness of identity and the uniqueness of inverse. Let's start with the statement uniqueness of identity and the uniqueness of inverse. Here two things we have to show, that identity element exists for a group will be unique, and another thing is uniqueness of inverse, which means for every element in a group G, they must have one and only one inverse. If there be two inverse exist, then both will be same. Okay. Statement, see here, statement can be written like that. Prove that identity element exists in a group uniquely. Okay, so if identity element exists in a group is a unique thing, and also every element of a group G has a unique inverse. These two things we have to show. First we are going to show the uniqueness of identity element. Okay, see here, let G binary operator, let B star. Okay, let G star be a group. So group, we are representing group like this, ordered pair. Okay, G and the binary operator, this is a representation for a group. Suppose E and E prime are the identity elements of a group G. We are considering here two identity element exist. Okay, but what we have to show, we have to show that there exists a unique identity element. We are considering for contradiction, if two identity element are exist, then what will happen? Suppose E and E prime are the identity elements of a group G, then by the property of an identity element, we know that from the property of an identity element, how? In first case, let it be treating here E as an identity element. Okay, in first case we are treating E because we are having two identities. So okay, E and E prime, treating here E as a identity element. So this one is identity element, and here this one is identity element. Multiplying this identity element with any element of a group, then we will have the element itself. So here what we are having, E prime, these two equals, taking reverse also, E prime binary operator, let it be multiplication, E prime multiply with E, the identity element, we are having the element itself. Okay, so this is the first statement where E is an identity element. Next, second thing is E prime also a identity element. Let it be E prime, treating E prime as a identity element in a second statement. So this one is identity element, and here this one is identity element. Multiplying this identity element with an element of a group G will be equals to the element itself, because this one is identity element, we are multiplying identity element with an element of G, though we will have the element itself. So here element will be equals to this reverse order, E prime multiply with E, we are having the element here, E prime as a identity element. These two things we are having here. Look, the right hand side is equal, so left hand side will be equal also. Treat from 1 and 2, from this statement and this statement, what we are having from 1 and 2, because right hand side is same, let it be this one and this one, these two are same, so left hand side will be same. What we are having, E equals to E prime. These two are two distinct identity we have considered earlier, but these two are same, so we can say that the identity element in a group is a unique. Next, what we have to show, uniqueness of inverse. Yes, look here, uniqueness of inverse, which means what we have to show, for every element there will be a unique inverse. If two inverse exist, then the two element will be equal, that two inverse will be equal. Okay, so consider here, let A belongs to G. G is a group. Okay, G is a group, so we are considering an element A which belongs to a group G. Suppose there exists two inverses B and C. Suppose we are considering two inverse exist for A. For this element we are having two inverses in G. These two will be an element of G. Okay, will be in G. By the definition of an inverse element, now applying the definition of an inverse element, how? A is an element, okay, and B is an inverse. So multiplying A and B, multiplying A binary operator B, let it be multiplication. A multiply with B will be equals to B multiply with A, and the multiplying this element and inverse will yield identity element, will be equals to identity element for the first one, for this B. Okay, what we have considered, we have considered that there exist two inverses. First one is B, second one is C. For which one? For the element A. So first we are multiplying with B. A multiply with B, and reverse order also, B multiply with A will be equals to identity element, because these two are this is the inverse element of this one. So what we are having identity. For the second case, is C. Let C also be a inverse element of A. Then multiplying A multiply with C will be equals to C multiply with A will give the result as identity element. So what we are having, identity element here also and here. Let it be equation number 3, and this one is equation number 4. Now consider. Now we are considering what? The element B. B can be written as B star E, because E is an identity element. Okay. So B star A multiplying with identity element will be element itself. Here E as an identity element. So we can multiply, we will have the same thing. Now B star A star C from 4, equation number 4. What? 4. What we are having? A star C will be equals to E. So replacing E as A star C from the equation number 4. This one. A star C, we have replaced here E. E become A star C by the equation number 4. Next thing, associative, applying associative law or associativity axioms. So we are making association, because associative law already holds here, because G is a group. G is a group. So associativity law, closure property, everything will holds here. What we have to show? We have to show that inverse is unique. So associativity law applying here, make it associative, B star A and star C. Now again applying the equation number 3. What we are having? B star A. B star A is B star A will be equals to identity element. Here we have replaced this B star A as an identity element, multiply with C by the equation number 3. What we are having finally? E star C is an identity element, multiply with C. What we are having? C. Right hand side is C and left hand side is B. B equals to C. Which one? This one. B and C. These two are equal, which means the inverse element is unique for any element in a group G. Thank you.